Your table is 5.8 megabytes on disk. The GroupBy that reads every row of it writes 3 kilobytes to the shuffle, 2,000 times less, because the aggregation happens before anything crosses the network. Measured on this machine, 8 groups, 5 tasks. What travels is the number of groups, not the size of your table. Pick the wrong key and the same query moves 65 times the bytes. Today, GroupBy, aggregations, and the exchange underneath them. Here is what actually runs. Your 4 input partitions each aggregate their own rows first, so a partition holding 10,000 rows hands over 8 partial results, not 10,000. Only those partials cross the network, and a final stage merges them into your answer. That is why 3 kilobytes was enough. Episode 2.5 of the course. The next one turns all this into SQL, so subscribe. Now the part that decides whether this is free or expensive. The shuffle is never expensive because your data is big. It is expensive because your key has too many distinct values, and nobody warns you when you pick one. Watch. Nothing about the table changes. Same 40,000 rows, same query shape. Group by user ID instead of endpoint, and the shuffle jumps to 194 kilobytes. 65 times more bytes, because you just asked for thousands of groups instead of 8, and every one of them has to travel. So what does one GroupBy give you? 8 groups, 1 per endpoint, with everything you asked for in a single pass. Requests, timings, average, max/API/search is the busiest at 5,081 requests, and the slowest single request in your table is 456 milliseconds. 1 exchange, 4 aggregates, 1 result table. If you ask for them in 1 agg call, Spark computes them together instead of walking your data again. And the nulls from last episode are sitting inside these results. Count star gives 40,000. Count of latency gives 38,428. Your average comes back 122 milliseconds, computed over the smaller number, silently. Per endpoint, it is the same story. /API/cart shows 5,012 requests, but only 4,808 timings. Your dashboard says average latency. What it means is average of the requests that answered. First ambush. Your 3 kilobytes were written into 200 partitions, because 200 is the default for shuffle partitions, and it has nothing to do with your data. Adaptive query execution catches it here and coalesces them down to 1 partition, which you can read straight from the output. On a bigger table, it goes the other way. 200 tiny partitions, a task for every one of them, and a job that spends longer scheduling than aggregating. Second ambush, and this one cuts both ways. countDistinct on user ID gives 8,719 in 0.97 seconds. Approximate countDistinct gives 8,409 in 0.83, 3.5% off, and on this table barely faster at all. That is the honest result. The sketch earns its keep when the distinct count runs into millions, not thousands. So measure your own data before you trade accuracy for speed. Let's reproduce it. 1 agg call with average, max, and count together, 0.51 seconds. The same 3 numbers as 2 separate GroupBys, 0.91. Nearly twice the time for an identical answer, because each GroupBy is its own exchange. It is the same rule as the columns episode. Build 1 expression, not 1 pass per aggregate over your rows. Every figure in this video came out of that script, shuffle bytes included, read from the Spark UI. So here's the rule. Aggregation happens before the exchange, so a GroupBy costs what your key costs, not what your table weighs. Before you write one, ask how many distinct values that key has. 8 keys are free, thousands are a shuffle you should plan for, millions are a design decision. Put every aggregate in 1 agg call so Spark makes 1 pass. And remember that average, max, and count of a column skip nulls while count star does not. Next episode, the same query written in SQL, and why Spark builds the identical plan whether you type Python or a select.